Hey there, Chem Squad. Alright, so we're going to name bases and salts. Now, bases and salts both use the same type of naming rule. Both of them use what we call the ionic naming rule. Okay. What this means is basically bases and salts, they fall under the same category as ionic compounds. So ionic compounds, if you remember, are things that always start with metals, and they also contain nonmetals. So when you look at bases, the only difference between a base and a salt is that the nonmetals are generally OHs. So let's highlight that. So you'll see that for each one of these three, you have what we call a hydroxide ion. And the hydroxide ion is, of course, a complex ion. The other cations that are attached to it are typically metals. Okay, so really the naming rule for bases are as follows. You always use the full name of your metal, so in this case, sodium, and then you add the word hydroxide to it, because that's the name of the complex ion. And it doesn't matter how many hydroxides there are. So for the second one here, you can see that there's two groups of hydroxide ions. But the naming rule still stands. You use the full name of the metal, so in this case it's magnesium, and then you use the word hydroxide. Okay. And then for the last one, aluminum, and then again you have a hydroxide. So basically for bases, it's the full name of the metal plus the name hydroxide. And that's all you really need for base naming. For salt naming, it's pretty much the same thing, okay, because it's still an ionic compound. Okay. Now, the only difference here is that your anion will likely change. So depending on what your anion is. Oops. In our example, we have bromine and chlorines. So all of these guys, okay, they also start with a metal, okay, but then for your simple ions, okay, they generally end with IDE. So when we go through these guys here, the first one is, of course, sodium. Right, because that's Na. And then you have bromine. So bromine basically turns into bromide. Okay. Now with lead, you gotta be careful because lead's a transition metal. Every time you have a transition metal, you have to figure out what type of charge it has. Okay, so for lead, you gotta go and look at its multivalent charge. So lead can either have a +2 or a +4 charge. Now, what's helpful is looking at the actual nonmetals that it's bonded with. Okay, so if Pb has a +2 charge, okay, and let's say Cl here we know has a -1 charge, that would make sense in terms of why it has 2 Cls. So for something like this, because we know that lead, Pb is lead, okay, this Pb must have a +2 charge. So we need to put in the Roman numeral 2. So this would be lead 2. chloride. Okay. This one here must be a +4 charge, okay, in order for there to be 4 chlorines. So this would be lead Roman numeral 4 chloride. Okay. So you see the naming rules again are the same. It's always the metal plus the name of the nonmetal, or in this case, the anion. The only thing that you'll see that might come up is what if you have a complex ion for your salts, okay? So for example, what if you have something like this, CuSO4? Well, again, copper is a transition metal, so copper can either have a +2 or a +1 charge. So for now, let's say +2 or +1. But sulfate, okay, SO4, okay, sulfate has a definite -2 charge. Okay, and if we only have one copper, then it makes sense that our copper is actually a +2 and not a +1. So in this case, it will be copper 2 sulfate. Okay, so notice that we don't change the ending at all. Okay, for complex ions, you always use the name of the complex ion. So all of these salt naming rules you should have learned in grade 10, okay, and they would have been used in grade 11 as well. So in terms of bases and salts, they're actually fairly straightforward. The only one that's a little bit tricky are your acids. So hopefully this guide has helped you a little bit, so that next time if I give you an acid, base, or a salt, you should be able to name each one accordingly. See you guys soon. Thank you.